is the CEO and founder of Phoenix Semiconductor Corporation. Ryan is a distinguished innovator with a rich and diverse career spanning a variety of technologies, currently serving as the founder and CEO of Phoenix Semiconductor Corporation. Dr. Hatcher is driving a novel solution to disrupt the trailing edge of the semiconductor supply chain. Dr. Hatcher's journey to leadership began with a pivotal role as the Chief Technology Officer at Ultra Command Control and Intelligence, C21, a key line of business within the British defense contractor Ultra Electronics Group. Before joining Ultra, Dr. Hatcher served as the corporate technology scout for Lockheed Martin, one of the world's premier aerospace and defense companies. Prior to his role, Dr. Hatcher served as the principal scientist in the Advanced Logic Laboratory at Samsung Semiconductor, which was tasked with defining the CMOS logic technology roadmap for Samsung Foundry at nodes N+3 and beyond. Dr. Hatcher holds a PhD in physics and a Master's of Science in Computer Science from Vanderbilt University. He has authored more than 50 influential papers and patents that have garnered over 350 citations. So I'd like to welcome Dr. Ryan Hatcher.
Thank you, Lori. Thank you, everybody, for having me. Really appreciate it. I should have told you to cut that short. It's very late, and that's very long. Is this the microphone?
Yes.
Or can they hear me
Yes.
if I walk?
Clickers.
Clicker's over here.
Right there.
Okay. All righty. So, yeah, I like to say my career has been a little bit like Benjamin Button, in the sense that it started my career, I was looking really like way out technology, 10, 20, 30 years out, crazy things that'll probably never work. I then went to Samsung, and I worked on things that were like 6, 7 years out. Your phone within the last like year or two probably has technology, which I have a patent, or I'm on a patent. Then I went back to Lockheed, I was working on technology that's sort of now. And then I started Phoenix Semiconductor really to focus on technology that's old. And we'll see why that matters and why people actually care and why you should care, because it's really important that things that are in production for a long time remain in production. So what's the real problem I'm talking about here? It's a problem that's been going on for decades. It plagues certain sectors of the economy, critical sectors of the economy. It's terrible, but everyone saw it. Almost everyone in this room felt this problem during COVID. Which is to say that if you wanted to buy a car or an oven or any number of parts, you couldn't. And the problem wasn't the latest and greatest. I mean, it wasn't a big NVIDIA Jetson. It wasn't an Intel CPU. It wasn't the big expensive chip in the middle. It was these little chips on the outside, the worker bees, that make the electronics actually turn on. And yeah, those big chips in the middle, they're important. They're super important. But I tell you what, if you don't have the UART that's sitting on the edge, the little glue chip, the board still doesn't turn on. And thus you have empty car lots. Now that was horrific during COVID and affected a lot of industries that normally weren't subject to it. But I will tell you that this is a problem that has plagued aerospace and defense, medical technology, industrial equipment, industrial manufacturing, commercial aerospace. These sectors have felt this problem for decades. And when I went back to Lockheed after being at Samsung, I talked to program managers all the time. I was a tech scout, and I was trying to find cool companies that had cool technology that was going to move them, into the 21st century. And they were like, I need this little, this little memory part that was originally manufactured in 2004, and it's screwing up my work. I can't get this. My radar system can't go in production. So I kept hearing this, and I was like, oh, eventually it kind of hit me like a ton of bricks. I think I know how to solve it, and I'll tell you the story of how we're going to solve it. But here's the fundamental problem. Now, you can say, well, wait a minute. We've got a semiconductor industry. They make chips. Why don't they make chips for aerospace and defense? Why don't they make chips for commercial aerospace? or industrials. And this is the fundamental problem. Hopefully this will resonate. I know there's some confusion about this look ahead stuff might be a little technical, but the bottom line is this: you've got all these different sectors of the economy that have different life cycles. Just think about the typical age that a product is in production for and how long it lives. So if you're talking about a phone, you know, the next version of that phone comes out next year. So if a part in that phone gets discontinued and is not available, who cares? Samsung's gonna design a new board with a new part that's available. If you're talking about an F-35, or if you're talking about an Aegis radar system, and a part goes obsolete, your production can be shut down until you redesign a board around it. And by the way, just like in medical devices, aerospace and defense has horrific certification requirements. So the second that you want to get a new part, you have to get that thing recertified. It's a disaster. It's super expensive and it takes a long time. And so it goes with automotive and med tech. And you might say, well, why did some of their companies discontinue? Well, look at where all the revenue comes from. 75% of revenue is driven from those short cycle sectors, the sectors where they have new products every couple of years. So they're just going where their money is. I get it. If you're a semiconductor company, you want to have new parts, you want to have new products every couple of years. You're going to get out with the old, in with the new. So this is a typical life cycle, pattern of a life cycle, where you've got a part goes in production, it stays in production for a while, there's demand, it's being consumed, and then the demand starts to tail off because those short cycle sectors go on to the next part. And at some point, the semiconductor company gets wise, that's that little red area, and they say, forget it, we're cutting off production. There's a last time buy opportunity. They shut off production, and then whatever's left is what you get. If you're out there and you need those parts, you better buy them. You better buy them in that last time buy. And normally so you end up, if you're a company that needs it, you can buy it to about here, and then there's no more parts and you're done. What Phoenix is wanting to do is unlock this long tail of demand. It's a long tail of demand from customers that have tremendous amounts of pain when that part's not available. And we think we can do it. We think we found a new way to do it. So what happens? You know, if you're in this industry, you've got a couple different options. You can do the last time buy. Of course, there's not always enough parts to satisfy all the customers for it. Some estimates say maybe 40% shortfall. You can go to a reseller or a broker for aftermarket parts. Tremendous amounts of counterfeit parts in the market. This is a shocking number. Every year, $7.5 billion worth of counterfeits impact these various industries. By the way, if you know anyone in these fields, they're all embarrassed, but they'll all tell you, yeah, oh my God, we had this program, it was due, we had a deadline, it was due. I bought a part from Malaysia, and it was a fake. And when I turned it on, the board went, smoke came out of it, and that was that. So, and then of course redesign, super expensive, costly. This is what we're doing, by the way. I wanted to show you we have a working prototype. We basically take an existing collection of parts you can get off the shelf and assemble them in such a way, so these are parts that you can get that are reprogrammable, and you can reproduce the behavior of the original part with this collection of parts that you get today. And it's a drop-in replacement. So for that part that was originally, this part is no longer available, we basically reproduce the behavior with this collection of parts you can get today, and you drop in a replacement. You package it up and you drop in a replacement. The advantage is that the upfront cost to do that design is really low. If you want to tape out if you want to make a new chip to reproduce, that's usually on the order of $1 million at least. We can do this, we think, for on the order of $10, $15, maybe $20,000 upfront cost. So we don't need to have high volumes. We can address the need of these customers. These customers have tremendous pain. We can address the fundamental mismatch, which is we can produce these chips for a long time. We can satisfy this market for a long time, and we can produce a lot of them at low volume and make a lot of money. And it solves a lot of problems for these sectors that are normally played. So you don't have it's essentially a new option. That's the first part. So that part that you're seeing now is our prototype. It's a proof of concept. Our second part is going to go onto a Lockheed Martin sniper pod. We're hoping to get that on board by June 1st. Again, it's a part that went obsolete in 2021. This is a critical weapon system that's on over 2,700 air vehicles. It's a pretty big opportunity. I'm not going to go through the numbers because I'm short of time, but it's we can certainly dig into numbers if you're interested. There's also a lot of data to back this up. I pulled this from a Department of Commerce study that just came out in December. Go to market. So we have two models for making money. One of them is going to be a traditional contractor model with the U.S. government, with government-type customers, where they're going to pay us to build parts. The second model is a commercial model where we're going to partner essentially with distributors. So distributors are like the HEB of the electronics world. You don't buy, most of your food you buy from HEB, not from the, Campbell's. So we're going to go right to the distributor. We're going to identify in partnership with the distributor what parts are most in demand. And then the distributors will actually purchase those parts from us. They'll say, look, we want 2,000 of this, we want 1,500 of that. We think there's a tremendous opportunity to get into market there. I'm going to skip this. This is how we get to scale on the design side. Here's an estimate of the profitability. Again, we're only going to make the parts for which the demand is high for those sectors where the capital, where it's high capital costs for equipment. So the cost of a chip to keep that part in production or in the field is trivial compared to the total cost of the vehicle. Leadership team, oh my gosh, I wish I had more time to talk about these guys, they're amazing. This guy, I can't believe that he reports to me. He was if you told me this 2 years ago, I would have said you were insane. He was the CTO of F-35 for 9 years. I'm out of time. Any questions?
What would you tell us about your fundraising and use of funds?
Oh, sorry, I got the stop sign.
That's a question.
That's a question, okay, yeah, I see. And yeah, so we just closed $500,000 from Lockheed Martin Ventures. I should say we just came to terms with them. We're going to close probably in about 2 or 3 weeks. We're looking to raise another $500,000. The purpose of this funding is to get us to the seed round. We're going to build. We're going to build parts. We're going to build several parts. We're going to put them on that sniper pod. We're going to use them to develop the Legacy Plus. I blasted through it, but it's the platform. It's our own design tool that's going to help us, that will automate the design process. So it's going to drive down the upfront costs. I said the cost that we anticipate would be on the order of $10,000 to maybe $15,000, $20,000. We think we can cut that down by an order of magnitude. The design cost, the upfront design cost. So proof of concept on the design tool that will help us get to scale, and then just simply building out parts. We also have an opportunity, we believe. We've already been working with an attorney. We believe there's probably a fairly solid IP landscape that we can build, that we can start to build with this use of funds. Yes, sir?
What prevents somebody else from repurposing their own chips?
Sorry,
what's your moat?
Right, so our key moat is speed. That's actually why that design tool is going to be so critical. This is doable. Like I said, people have demonstrated this before in simpler systems. What we're really trying to build is, it's essentially the design automation toolkit. And we think that it's just speed. So we think that with this approach, and blasted through it, but one of the key members on the team is a tool development expert from UCLA. So we've outlined a plan to build this, and it's just the time and money it takes for us to put a new SKU in the market. We think is going to be an order of magnitude smaller than anyone's doing it by hand. Yes, sir.
I've got one that I'm probably not on your radar right now, but we're building automobiles right now that are full of chips. There's roughly 47% of the population of the United States that will probably never own an electric automobile.
Yes, sir.
They buy used automobiles today, they're 15 to 20 years old, they have 150,000 miles on them. Those same vehicles today that reach that stage, they're not gonna have chips available.
Yes, sir.
So these guys need to be able to work on their automobiles. Where are they gonna get those chips?
Yeah, I mean, that is a potential. So it's a great observation. Our strategy is to use the point of sale information, the analytics from the distributors to identify the next part to make, for which there's gonna be the most demand, highest volume, highest margins. If there's a market, if there's sufficient demand from people who want to keep those vehicles in the field, then yeah, we'll make it. But it'll be filtered and sort of collated, the demand across from everywhere. Another area that I think could end up being very profitable is the vintage car racing community. There's a tremendous amount of money. I live in Austin. There's COTA. The Circuit of the Americas is right there, and I take the boy out to COTA. You can't believe the amount of money that people pour into these cars. I think there's a lot of demand there as well. Yeah.
One of the sound bites that may help you understand the pitch here is he's targeting these weapon systems and other complex, expensive systems, right? That have multi-million-dollar systems that have a nickel part that's getting in the way of multi-million-dollar sales. So he said, this is a nickel standing in the way of a dollar, and they're really coming up with a scalable way to retrofit current chips to behave like older chips.
Yeah, and it's perpetual. So as the parts that we're using are discontinued, we can update with what's available today and basically restore.
So a couple of questions. One, so the company's based out of Austin.
Yes, sir. Austin, Texas.
Have you already been successful in running trials on this? I know we have the samples here, but has
So that's our first prototype that's being actually. So that board that I showed you earlier, that's the board for a Game Boy, and that's our first demonstration. I thought it would be kind of fun, and so we got that back a couple weeks ago. It's still being debugged and worked on, but yeah, next time I see you guys, I'll bring the Game Boy. You guys can play Tetris.
right.
Can you say a little bit about that Lockheed Martin process, like how they selected you and sort of the diligence involved?
Lockheed Martin Ventures.
Yeah.
Yes, sir. Yeah. So, So this was so Lockheed Martin Ventures is a $400 million fund. They invest in companies that have technology that are strategically aligned to the needs of Lockheed Martin. I think they've got 25 or 30 active companies in their portfolio at the moment. The way it works is they find interesting companies they think are aligned, and then they have to get at least one or hopefully multiple lines of business to stand up and say, yes, this is important. So they need to have their executive leadership from the business areas. So Lockheed Martin is, it's basically four $15 billion companies. Aeronautics is just one of them. To stand up and say, yeah, this is important to us. And so we got the Missiles and Fire Control Division to do that, as well as the Aeronautics company. We had support from two of the four business areas. And they just say, yeah, I mean, our primary champion was Mrs. Fire Control because of the sniper pod. The program manager saw that as a home run.
So when you complete that agreement, what does that mean to the organization? Is that, are you getting quite a bit of funding? Are you gonna be running the first prototypes? What is?
So the funding is just a convertible investment.
No. With your agreement with the venture, are they putting money in to help, you know, develop just the whole part of the company to develop these chips, to be able to support Lockheed Martin, I'm assuming?
So, sorry, the Lockheed Martin Ventures investment is it's just like a venture capital.
That's all they're doing,
It's
they're just
yeah,
gonna invest into.
It's just a straight venture investment.
Okay.
It's structured.
So I guess the question would lead into then, do you already have a target? Let's say you have all your funding, you have everything in your pocket, you already have your first target customer that you're going after, that you're gonna be developing with this activity?
Yeah, so the first part we're making for Lockheed is that replacement for the sniper pod, yes. It's in the and then there's another group within Mrs. Fire Control that has expressed interest. I don't know what specific part they're looking for. I mean, we've got a lot of lures in the water, to be honest with you, so.
I guess the reason why I ask is because as you know, an Angel Network, if we decide to invest into it, you know, we're also trying to see, okay, what's the end strategy for us? Is this,
Oh, I see, yes.
you know,
yes.
and
So,
and how far
I
along
gotcha.
that pipe
Yeah.
are you already to being able to produce product, and you start showing returns and into the company, and how's that all gonna go into that developmental process?
So I think, I understand your question now. So the exit, we believe the exit is gonna be an acquisition. I think it'll be either from a tier 2 supplier, so this would be not like a Lockheed or a Raytheon, but like a Mercury Systems or a BAE or an L3. These are the types of companies that are hit most directly by this obsolescence problem. I think it would provide a competitive edge for them. Or possibly a distributor. The distributors can also realize a competitive advantage because they, you know, if Avnet partners with us exclusively, they will be able to provide high demand parts for customers that are in a lot of pain, and Arrow will not, their competitors will not. So those are sort of, I believe those are our two most likely exits by acquisition.
You have some financial projections on when you're gonna start, your first full year of revenue, what it'll look like?
Yeah, so I had a little bit of that. I mean, we have sort of a growth, I mean, it's a very rough estimate. I've got more of a detailed breakout. We can examine another setting, but yeah, I mean, the bottom line is, you know, we assume that a fairly modest, I mean, back it up. One of the advantages of this approach is that our upfront costs are very modest. The cost for us to put a new SKU, a new part into the market is very low. We don't have to sell a lot of parts to realize a very substantial profit. So in fact, for this, you know, our target is 500 parts per. I think that's very modest. I think that we'll probably be looking more for parts that will have, say, a couple thousand. So these are the types of numbers. If our catalog has 50 parts, we think we can make, you know, EBITDA is going to be on the order of, you know, 3 to 4 million. And again, it's because we're selling these parts for a lot, because the demand is high by definition. Yeah.
Well, at $120 to $360 million in revenue and EBITDA, that you ought to be able to go public.
That's another option. Yes. Yeah, I mean, it's I don't know. Well, the landscape has changed for M&A, for sure. And I would say a couple of years ago, that would be, you know, with all the SPACs, that was happening a lot, and earlier. Now it's you know, it's hard to say what's more likely, going public or being acquired. I don't know. It's a problem I would love to have.
That's right.
And on that one part, the sniper, piece, like what is that piece, like what's the price of that?
Yeah, so that part is, I mean, now it sells for $7, and we would probably sell it for 100, maybe 150. That's what we're looking at. Yeah.
But the whole system,
Oh,
The sniper
system,
pod,
oh
yeah.
gosh, sniper pod is, I think the latest version is $8 million, I forget how much. But that's the dime hole of $1, yeah, yeah.
right?
Yeah, I mean, you're not gonna, what, yeah, no one's gonna bet an eye.
But that $8 million system won't work without this $7
Correct.
piece.
Correct. Yeah, yeah, that's right, that's right. Yeah, it's a crazy system, but that's just, you know, it's just this little bit that stores information that only gets used when the system gets turned on. It's used one time, it's turned on, it loads the information, and then it turns off for the rest of the time. But, you know, doesn't matter, you don't have it, doesn't work.
Thank you.
That's good. Thanks, everybody, appreciate it. For sticking around.